So let's take a look at some more carbohydrates. Well, this is an example of some monosaccharides like glucose and fructose. You can see they have very similar structures, but slightly different depending on where the double bond to the oxygen lies. In this diagram here, we can see a few different ways to draw cyclical molecules. If we use a structural formula, this means that we're actually showing all of the different atoms and what they're bonded to. An abbreviated structure is leaving out the carbons, and instead each of these corners here represent a carbon. And a simplified structure is not going to show the hydrogens or hydroxides, or hydroxyls, but it will show just a corner. And so whenever you see the corner, you can assume that there's a carbon and a hydrogen and this hydroxyl here. So don't worry about this too much. It's just a different way that we can draw the same molecule. In biochemistry, we use different types of drawings to represent different types of data. So what happens if we join together two monosaccharides or two carbohydrate monomers? Well, then we can form something called a disaccharide, and di is a prefix that means two. So disaccharide means two sugars. And how do we join together monomers? Through dehydration reactions. So let's take a look and see how that works. Well, we'll start with two monosaccharides, glucose and glucose. And if you look here, you can see this OH on one side and an H on the other side. If they join together and form a water molecule, well, then we are dehydrating these molecules because they're losing water. And as they lose water, the two glucose molecules can join together and form a disaccharide called maltose. So maltose is a disaccharide composed of two glucose monosaccharides joined together through a dehydration reaction. So, section 3.6 from your textbook is talking about kind of a health concern, especially in the Western world. People are eating too much sugar. So, in America, there's an organization called the FDA, and they recommend that only 10% of your daily food that you eat, only about 10% of that energy should come from added sugar, which is still a little bit high, but there's a reason for that. Because if you look at the amount of sugar that the World Health Organization recommends, it's about 20 pounds a year, which is about 9 kg. The FDA recommends about 40 pounds, but the average American consumes about 130 pounds of sugar every year. So that's pretty crazy. So anyway, try to cut back on the sugar because too much sugar can give you health risks like diabetes, type 2 diabetes, as well as some certain heart conditions. Let's move on. So what's a polysaccharide? Well, poly means many, so polysaccharide, many sugars, and these are long chains of sugar. So for example, starch and glycogen. These are two different polysaccharides. Starch is an energy storage polysaccharide found in plants. Glycogen is an energy storage polysaccharide found in animals. Cellulose and chitin are not for energy storage. Instead, these are the structural polysaccharides. Cellulose is found in plants, and chitin is found in mushrooms and fungus, and it's also found in the exoskeleton of insects. So if you ever look at an insect, like an ant or a beetle, and the outside of their body is hard, well, that's actually not a bone. That's a structure called an exoskeleton. Exo means outside. They have an outside skeleton composed of this polysaccharide called chitin. This is something you should know for the test. So starch and glycogen are for energy storage. Cellulose and chitin are for structure. Starch is found in plants. Glycogen is found in animals. Cellulose is found in plants. Chitin is found in insects and crustaceans, and it's also found in fungi. And in the next video, we will start looking at lipids.